Find the derivative of f of t equals t over the square root of t squared plus 1. I'm going to go ahead off the bat. Anytime I see roots, I rewrite them as exponents straight away. So let's call this, no, we don't want that color. Let's call this f of t equals t over t squared plus 1 to the 1/2 power. Okay, so we've talked about the four main derivative rules: the power rule, the product rule, the quotient rule, and the all-powerful chain rule. So it looks like on these list of our four general derivative rules, 3 of them apply to this problem. So we have the power rule because we have the 1/2 power. We have the quotient rule because we have a quotient, we have a fraction, and the chain rule because in the denominator we have an expression that can be written as a composition of two functions. Or we have an inner function, the t squared plus 1, and an outer function, the 1/2 power. So it looks like we're not going to use the product rule here, but we're definitely going to use the power, quotient, and chain rules. All right, so let's see what this looks like. The derivative of f of t. Well, we'll start with the quotient rule. So this is where we start because the quotient rule, so the power rule only applies to this power, the chain rule only applies to the denominator, but the quotient rule applies to the entire function. Okay, so quotient rule. It's the denominator, t squared plus 1 to the 1/2 times the derivative of the numerator. So low d high, the derivative of t is 1 minus high d low, or numerator, times the derivative of the denominator. So this is where we use the chain rule. So the chain rule says for the outer function, the 1/2 power, take the derivative of the outer function, right? Inner function stays the same, t squared plus 1, and then we multiply by the derivative of the inner function. The derivative of t squared is 2t, and the derivative of 1 is 0. So this is where we use the chain rule. All right, so let's see if we could do some simplifying here. Derivative of t, or derivative of f of t, f prime of t. All right, so we have a t squared plus 1 to the 1/2 power. Oh, sorry, we forgot the denominator. Oop, so this is all over denominator squared. So t squared plus 1 to the 1/2 squared. So the 1/2 power and the square, they cancel. So t squared plus 1 to the 1/2 power, and that's all squared. Okay, so let's see. F prime of t. All right, so we have a t squared plus 1 to the 1/2. Then over here, we have a t and a 2t, so that's 2t squared and the 1/2, so the 1/2 actually cancels the 2. So we'll have a minus t squared over t squared plus 1 to the positive 1/2. So we can move this negative 1/2 power to the bottom of the fraction. And then this is all divided by t squared plus 1. Because the 1/2 and the 2, they cancel. All right, so let's combine these two terms in the numerator. That should actually be blue. So let's multiply this first term by t squared plus 1 to the 1/2 over t squared plus 1 to the 1/2. So now we have a common denominator. All right, so this t squared plus 1 to the 1/2 times this t squared plus 1 to the 1/2. We add those exponents, so that's t squared plus 1. T squared plus 1. And then we have a minus t squared. Oh, okay. And that's all over t squared plus 1 to the 1/2 power. That's just the numerator here. So we got a common denominator and combine these two terms into one. And then on the bottom, we have a t squared plus 1. All right, so it looks like this t squared and this minus t squared cancel. And we can simplify this compound fraction. So if we put this over 1, and we could say, so the numerator here is, the numerator here is 1 over t squared plus 1 to the 1/2 power. And we could change the division to multiplication, so we can multiply this, stay, change, flip. We can multiply this by 1 over t squared plus 1. So we have a t squared plus 1 to the 1/2. We have a t squared plus 1 to the first power. We could add those exponents, and we have 1 over t squared plus 1 to the 3/2 power. Okay, so as I've said in previous videos, when you're applying one of these derivative rules or a combination of these derivative rules, step 1, apply the formula. And step 2 through n, 2 through the end of the problem, is algebra. So in this case, we were able to simplify this first expression, which was the initial result of applying the power, quotient, and chain rules, to this nice compact expression.